All right, in this video we're going to look at how we can derive expressions for the maximum velocity and maximum acceleration for a mass spring oscillator in terms of the frequency and the maximum stretch, the amplitude. So take a horizontal oscillator or a vertical oscillator that oscillates between equilibrium left and right here, up and down here, and remember from the equivalency that these will operate in the same manner, where we know the total energy at any given point will be a combination of spring potential plus kinetic. So 1/2 k times whatever the x is, the stretch of the spring, squared plus 1/2 mv squared. Now we also know that when the oscillator reaches maximum displacement, let's call this positive A, it has a speed of 0. It changes direction. So my maximum total energy can be found if I know 1/2 k in A, the maximum stretch squared. Now, as it slides back towards equilibrium and reaches equilibrium, the whole time it's accelerating, and so it's going to reach its maximum velocity at equilibrium. So V max will occur at a position of x equals 0. And you can see that from conservation of energy. If I look at my expression for energy, when x is 0, then all the energy is kinetic. And so if energy is conserved, so if we have a conservative system, which a mass spring system is in the absence of friction or resistant forces, then we can see from that equation when x is 0, this term goes away, all the energy is kinetic, meaning V must be its greatest. So we know that E max could also be found knowing 1/2 m, the speed at equilibrium, which I'm going to call V max squared. So let's set these equal to each other. 1/2 m V max squared, the maximum kinetic energy at equilibrium, has to equal 1/2 k A squared, the maximum spring potential at max stretch. And we see the 1/2s cancel, and very quickly I can see V max is equal to, I'm going to divide the m over here, k over m, but then I have to square root it, so square root of k over m times A. So there's one way we see the maximum velocity of an oscillator that can be found, but we want it in terms of F and A. So think about this term over here. Remember that the period, or let's do it in terms of frequency. The frequency of a mass spring oscillator is going to be 1 over 2 pi times the square root of k over m. Well, wouldn't you know, we have that root k over m here, right? So if I bring the 2 pi to the other side, I have 2 pi times the frequency is equal to root k over m. I can rewrite this as V max is equal to 2 times pi times the frequency times A. And that is a common expression to be solved for with a mass spring oscillator.